Senior researcher Ulrich Pulg from NORCE is getting ready with the microphone. NORCE is an independent research institute that conducts research to facilitate informed and sustainable choices for the future. Welcome, please.
Good afternoon, everybody. We are about to jump right into the refreshment of the day, into the cool and clear waters of Norway. I have the pleasure to tell you something about the work of the last decades. You know about that. You know about the Water Framework Directive, about the conflicts, about the problems, about the guidelines that have been published. And we have the possibility now to look how it went. How did it go? I present you now a bunch of projects that we were involved in, about the costs and how the effects were. And in the end, I will discuss them with you. We start right now with the ripping of armored layers. It's like plowing of river bottom, a typical effect when floods are lacking. The natural sediment transport is disturbed, and you get an armored layer. You can rip it. It works fine in semi-fluvial and non-fluvial river types, meaning that we have a glacial river bottom with kind of big boulders, about 50 centimeters, 20 centimeters, and we remove the fines, the clogged fines, and remove also a cover of moss that would usually be removed by floods. We have costs of about 10 kroner per year, per square meter, and have had very good performance over up to 10 years. In fluvial sediments, we only had 1 year. So this depends very much on the sediment type and on the sediment transport. But in Aurlandselva and Suldal, up to 10 years expected, and we have had an amazing response of fish densities. Big juveniles of trout and salmon need cavities in the river bottom, they need shelter, and they respond very much to these measures with about a doubling of the par densities in Aurlandselva and three doubling in Suldalslåga. The next one, spawning gravel augmentation, very widespread in the world, a very common mitigation measure. We have typical costs in Norway of 180 kroner per square meter. And I give you the number, the year of these kronas, because the krona is in free fall at the moment. So it's very good to look at the year when this was measured or calculated. And additionally, you see a number here. You see 4 to 12 kroner per square meter per year. That means we have calculated these cases there over the time they were functioning. In Aurland, for example, 10 years. And that gives us a good number for including maintenance, refill of such measures. The response of the fish is quite significant. In this article from 21, we found a significant increase in both fry and par densities of salmon and trout after these measures over 18 years. Boulder placement, also this one is a very popular one, especially in these rivers here in Norway, where we have natural boulders in a wide array of river stretches because of the glacial past of the rivers. Here we usually have costs of 700 kroner per big boulder or small boulder group, and if you calculate it per area, about 60 kroner. Also here we have a quite good response of fish if this is done properly. Here, for example, on the right-hand side, you see the number of adult spawners in Farfjordelva, a channelized river stretch where this was done, where fish find more shelter and aggregates afterwards. Also, juveniles can have benefits from such measures. Here, for example, data from the Tegdalselva, from Evini and Sven Erik, a colleague, who has measured these changes of fish densities in areas with and without boulders. Riparian vegetation, very important for birds, the vegetation itself, and insects, fish, and last but not least, bank stability. In these projects, we have about 28 to 98 kroner per meter of river stretch and have a very long endurance. If this is not taken down, it's working for a very long time. Large woody debris, here we don't have these long endurance periods because this is washed out again in floods and is simply rotting. But combined with natural riparian vegetation, this works also much longer because this gives a refill. Here we had 25 krona per square meter and measure different effects, again, depending on the river type. In fluvial rivers with sorted sediment and little shelter, there's a big and good effect on fish densities. Fish aggregate there. But in semi-fluvial types, with a lot of natural shelter in the river bottom, this does not have a significant effect. We're coming with a paper in a few weeks where we show these data. Management of submerged nuisance vegetation, it's the Krypsiv, Juncus bulbosus in Norway, which really fills up some regulated rivers. And we have a big, long experience in the south of Norway with removing and maintaining such vegetation, about 10 krona per square meter and year, and have to think of the ecological effects. Gaute is sitting here, he has found that not all of this removal is very good for the invertebrates and fish because it makes a homogenized river stretch, and then you have lower fish densities and macro invertebrate densities. Environmental flows, do they work? Here an example from Dale-elva in western Norway. We have, of course, some high costs and we slip water flows, and this is voluntarily, but it also has a very important effect on the ecology. In this case here, presented by salmon and brown trout smolt production in this heavily regulated river by applying these mitigation measures, including the voluntarily water flow of 300 liters per second in the upper part of the river. We can maintain a quite big smolt production. These are measured here with mark and recapture, 9,000 to 14,000 individs, which gives a okay smolt production for such a river type. The same applies for the Burayo River, where it was possible to adjust water temperatures and increase water-covered area by a higher residual flow. And this one didn't even cost anything because this water was taken from the tourist water flow of the waterfall. You've seen it in the beginning today. Anders Iversen showed the waterfall. And for this test period, it was the same amount of money that was spent, but it was much better for the fishes in this river, and it has a clearly positive environmental effect. Another one is the mitigating of effect of hydropigging, and this one is going to be presented by Sissel and Christoph tomorrow. It shows how we want to adapt the river bottom by applying natural river types to decrease the area that is going dry in the hydropigging, while we maintain good habitat quality. This is based on natural river types and 2D hydraulic modeling. More on this tomorrow. Fishways. Here we have a much longer endurance and we have a very high effectivity calculated over time because we often can get a large habitat connected. And if you calculate it by the money spent and the area gained and the time functioning, you get a very good cost efficiency of 0.04 and 0.09 krona per square meter and year. Fishways in culverts. Here we have projects where we have about 20,000 krona per square meter for natural river bottom through culverts, working very fine. The river is going just through it, but it's very much cheaper to just put in a ramp in existing ones. It is also a solution that allows at least a migration. The fishways for bigger hydropower installations, they have changed a lot today. You have heard from Oda already that we have a new types of fishways in Norway that are both addressing downstream and upstream passage. And these are coming. They are coming now after these guidelines that we have published 7-8 years ago. And it's really promising to see that this is implemented and realized in real life. Here the example from Palmafossen, 19 million kroner, the fine screen, it's a bitter screen, 12 millimeter, and we have upstream vertical slot path of up to 5 cubic meters per second and a downstream bypass with 2.7 cubic meters per second. It's not completely evaluated, but the first monitoring results are really promising. We have fish going up, and we have fish going down, and have no fish seen on the screen or in the turbine so far. Many new examples like that in Norway. That's really promising, and that's showing also that things are working. If we get new standards and new measures published, and people implement this, it's working. And I always remember the comment of the project leader in WOS Energy. He said, if the authorities demand this, we will do this. Total dissolved gases are a problem in many Norwegian power plants, and we have big projects analyzing this, but here just a solution for a very simple method to aerate the water in the Odra River. We have installed the deflector here, together with Odra Kraft and O Energy, and we see a clear effect where we reduce levels of 120, 130% saturation down to values below 110. Sediment management, here an example from Naustdal, protected river. But what does it mean, protected river? A lot of things are allowed there, nevertheless. So channelization is very common in protected rivers. Fine sediment input is very common. And that happened in the Naustdal, and the water level was rising, the sediment level was rising, it was destroying the natural habitats, and it was a flood problem. We implemented the removal of fine sediments and putting back the coarse sediments while forming natural river types again. And this project had costs of 30 krona per square meters, works in 6 years, and it's still looking good. So this is working for a longer time with a clear response of the fish in this area. It is data from Nina, Ola Ugedal, who observed and monitored this area before and after. And you see here the arrow where the measures were done, and the red ones, the bigger par of salmon that really exploded after these measures. Nature-based solutions. One example here for flood protection, where we try to remove canals and riprap and instead establish a nature-like bank protection based on riprap, but with enough space for a nature-like sediment and stone boulder layer on top. This is then combined with a natural riparian vegetation, and you see a clear effect again of the fish. The red ones here in the canal, and the green ones, they are on a nature-based stretch just above. So this needs a little bit more space, but gives a much better condition for both adult and juvenile fish. Another one, dam removal, Tromsø, 2.9 million spent, mainly paid by the Miljødirektoratet, initiative of a local sport fisher association. Restoring ground sills, here an example from the regulated Aurlandselva, working very well, 4 to 60 krona per square meter, works usually in the long run. And we have a clear effect here, data from Nidelva, where we have a big increase in juvenile densities after the measures. It goes from an impoundment to a river again. Restoring side channels, very promising. Here data from the Aurlandselva, a regulated river, typical costs 200 krona per square meter. And we have a clear response from nothing, because it was dry, to a production of about 10,000 to 12,000 juvenile fish in just this one side channel. And these side channels, they have another benefit. These side channels restore a part of the floodplain, and this floodplain then can help us to handle the big floods. Here is a flood modeling of Christoph Hauer and his colleagues in the Flood and Environment Project that shows how these black arrows here, how these water floods are going through this floodplain without destroying anything. On the right-hand side of the river, you see the red arrows. There the flood destroys houses and infrastructure that was placed into the floodplain. So this restoration has much more benefits than just for fish. Discussion and the summary. Out there are many good practice, many best practice solutions. It's simply to apply them. They're very relevant for the Water Framework Directive, for the relicensing, the taxonomy, and of course, they cost money. What I have shown here, for example. But you have seen that this money, this does not break the bank. If you calculate this over the time they're working, it's really not expensive. Another thing is that we have seen in these projects that good ecological status, not just potential, is possible in many regulated rivers. Not all of them, but in many. And then you may have noticed that there is a big difference in the performance. I showed some good examples now, but I've also mentioned that there are just projects that have just worked 1 year, or did not at all, or 5 years, not always 20 years, or 10 years. Why is there such a big difference? It is because these methods have to fit to the river typology, to the hydromorphology of the river. It doesn't make sense to put in gravel in a steep cascade, and it doesn't make sense to put big boulders in a small river when the water is then going out below it. So that's why we have come up with this river typology and these publications in the last years. And we use this every day in our work when we analyze rivers and when we analyze the measures that we can use or not use. And I'm very proud to say that we have a cooperation with Havelvatn and Miljødirektoratet. We want to establish a common Nordic river typology based on the very good work that the Swedish colleagues have done and the work that we have done in Norway. So when this is working, we have a good tool to have as a basis for the mitigation measures in future and for analyzing the rivers. Remember, I've just said, if good ecological status can be reached in some regulated rivers, what does that mean? It means simply they should not be heavily modified rivers. By definition, they should be normal rivers then, and good ecological status can be reached. This is due in the rest of Europe, where many regulated rivers aren't classified as heavily modified. This is very relevant for Norway, where in principle, all regulated rivers are classified as heavily modified. Imagine, what if regulated rivers would achieve good ecological status, not just potential? Wouldn't it be great? Not at least for the hydropower industry? We have learned that measures and their performance depend on hydromorphological conditions. The Swedish call it målbilder. The German-speaking language countries, they call it Leitbild concept. And this is a very good one because it is also the basis of the Water Framework Directive, the reference status. It makes very much sense, especially in Norway, where we have little impacts and still have natural conditions left. This is what the river would do anyway in the very big floods. So we work with nature, not against it. And that's what we call restoration. And that includes restoration of processes. We remove the impacts. And I've shown this is also possible, at least partly, in regulated rivers. We can remove ground silts. We can remove small wears. We can also restore side channels. This works self-sustaining and is often permanent and includes natural habitats of all species, not just salmon. And that's very important. We have learned this today. It's in the future not enough to address 1 or 2 species. We have to handle biodiversity and the nature crisis. If we can't do this because there are so many impacts and we want to keep them, we can choose a lot of mitigation measures, but then we have to include maintenance. And that's why we come up with these numbers per year, and you can calculate maintenance and include it in your budget. Another one, when we go on now in the next 10 or 20 years, we can choose different roads. And I'm not against environmental design. I've taking part in it. I have shown pictures, I have shown examples of it, and I'm contributing to it. But if you want to really include not just 1 or 7 species, but nature types and the whole bunch of species, you should really go for the road of restoration and take this as a concept with a mall builder, light build concept, and making as much possible according to this road ahead to restoration and a reference status. Thank you very much, all of you. It was only possible with the cooperation of many of you here in this room, including the authorities, the management, the industry, and the research partners. Thank you.